just a couple of picture problems we need to work through, which means you get to enjoy some lovely artwork. But okay, a flagpole casts a shadow that is 12 feet long when the sun makes a 64-degree angle with the ground. All right, let's draw that real quick. Okay, so here's my flag. Oh, and I didn't leave room for my sun. Okay, here's my sun up here. Dangerously close to the top of that flagpole. And a shadow is formed because the sun is behind the flagpole, shining down like this. Okay, and so there's my triangle right there. Everyone okay with that setup? Really, if you just wanted to draw the triangle, that'd be fine, but it's way more fun to draw flagpoles and suns. So, okay, where is a shadow located? On the ground, right? I have a lot of people who like to put the shadow on this line, okay? But the shadow would be down here. This is the shadow, okay? And so that shadow is 12 feet long. The sun makes a 64-degree angle with the ground. So where does that 64 degrees go? On the ground, right? Read that carefully. If it's where the sun meets the ground, it's going to go here. And then the thing we're looking for is the height of the flagpole, so I'm going to label that X. Okay? So sometimes drawing the picture is half the battle. What trig ratio is going to help me out here? Tangent, yep, because I have opposite and adjacent. So I'm going to say tan 64 equals x over 12. When I put over 1 and cross multiply, I'm going to end up doing 12 times tan 64. And then 12 times tan 64, my calculator turned off, that's helpful. About 24.6. Good, you feel like you could have handled that one? Yeah, good, okay. All right, let's do an angle of depression one. Okay. Okay, I know this problem is about a person looking down from the top of a building, okay? But I'm going to do another quick example, not with numbers or anything, but quick example to talk about this term, angle of depression, okay? Angle of depression is the same as an angle of descent, okay? And the easiest way to think about an angle of descent is with an airplane, all right? So here is my airplane. Whoops. There we go. All right, that's my airport. Here's my airport. The wing is incomplete there. All right. Got to be attention to detail here. All right, there's my airport, right? And so a lot of the times in these problems, you get an altitude, so you know how tall or how high up the plane is. And then you know that the plane's going to be descending towards the airport, okay? And when you have a problem like this, because you're going to run into one of these at some point, it's going to talk about the angle of descent. Like the problem will probably be asking you to figure out what angle the plane needs to turn at to get to the airport. And almost everyone, the first time they do one of these problems, is going to label that angle here. Okay? I want you to think about that for a second. You're saying, what angle should the plane turn at? Is this how you want your plane to turn? That means that your entire flight, the plane has been flying like this. And then when it gets to the airport, it just turns and flies straight to the ground. Okay? And when you calculate that angle, it's going to come out to be like 84 degrees. I want you to picture turning at an 84-degree angle on an airplane. That's terrifying, right? But it doesn't stop people from writing that down as their answer. Okay? The angle of descent is actually, if you picture kind of the plane has been flying like straight this way, the angle of descent is this angle out here. Okay, it's the angle that the plane is actually turning at to make it to that descent, right? And because we're good at geometry, we know that this angle would match what other angle in this picture? This one, right? Do you remember what those kind of angles are called? Okay, it's alternate interior, but close enough. Okay, AIA, alternate interior angles. When you've got the, like these two lines would be parallel and then the transversal. So this angle and this angle are the same. Okay? But it's a little tricky because when you first draw your picture, this angle doesn't really show up unless you draw in that imaginary line. Okay? And you're going to automatically want to label this angle. This is not an angle of descent or an angle of depression. Angle of descent or angle of depression always come from a horizontal line. You always have to go from a horizontal line downward. Okay, so just wanted to kind of cover that before we launched into this problem. Okay, so now, we've got a building. And we have a, oh, you can't see my building. What a shame. Okay, here's the ground. You've got a person on top of that building. And his assistant is down here on the ground. I'm assuming this is some sort of construction worker. I don't know, I'm making up little stories here. So this guy's 6 feet tall. And he's looking down at his friend. Okay? At a 28-degree angle of depression. So where does the 28 degrees go? Yeah, it's, so if this guy was looking straight ahead, and I mean, I made him looking from like his waist, but whatever. Oh, you guys are going to enjoy some good pictures in this chapter, for sure. This is really your 28-degree angle, okay? Which means, if I fill this in, this angle would also be 28 degrees, okay? Now, why didn't I make this go all the way down to the ground? Looking at the top of his head, right? And so we're going to have to deal with this 6 feet tall in just a second. But are you okay with the placement of the 28 degrees there? Good? Okay, and I feel like there's another piece of information. Oh, the assistant is 40 feet from the base of the building, so that's this. Okay, this distance is 40 feet. And I am guessing we want to know how tall the building is. So we've got our triangle there. Everyone okay with the lovely artwork there? Okay. When I find x, is x my answer? What do I still have to do?
6 feet.
Yeah, so actually I'm adding 6 feet because the x is going to represent like from here to like this guy's sight line. But then this is an extra 6 feet. And so if I want the total height of the building, I'm going to find x and add 6 to it. Okay, Emily?
I have a question about that then.
Yeah.
Isn't the guy looking at a 28-degree angle from his eyeballs? So
I was just going to say,
yeah.
yes, technically that should probably go to the top of his head. Okay. It didn't give us his height to work with, so I'm not going to stress about it too much. Maybe he's laying down. Maybe he's laying down on top of that building and looking down. I don't know. Okay. But I would say if it doesn't give you the information, don't stress about it too much. Okay. The only reason this was significant is because it did say that he's looking like at the top of his head, you know, and that's why we made sure to make this go to the top of his head. But you're right that we should actually factor in the height of this guy too. Okay. But if it doesn't give it to you, don't stress about it. Okay? Okay, once again, this is going to be a tangent problem. Actually, the trig is going to be very similar to the last question. Tangent of 28 equals x over 40. And then I'm going to end up doing 40 times tan 28. And I get that x is 21.2. And so again, making some assumptions here, this distance would be 21.2. I'm going to add on the 6 feet of this guy's height, and so the building would actually be 27.2. You okay with that?
Yeah.
Okay. So 27.2 feet would be your height of the